So here we are again. Let us continue. Unsigned less, signed less. Let us start with signed less. Signed less seems to be the easier variant. Since we can, no, actually not. Unsigned less would be the easier, I guess. Create a circuit that outputs green when the first input is less than the second. Interpret the bytes as being signed. That would be unsigned, right? Yeah, that would be signed. Let us start with unsigned less. Create a circuit outputs green when the first input is less than the second. Interprets the bytes as unsigned. Yeah, we already created these two circuits in a previous level. If you remember, we created these circuits when we created the, where is it? The conditions component. But since we cannot use our custom components in these levels, we will have to create it again, and we are going to do it by using an adder. Math. So first of all, we're going to add these two. And negate the second one. So what will be the outcome? -1 plus -0 is -1. So it's 255 less than 0. And now, if this byte is not... No, this doesn't solve it. Sorry, this is, I guess this is actually the solution for the signed less. Is that correct? Does this make sense? Yes, it is. Maybe if we just add them. No, all of this is wrong. I guess we're going to go by rebuilding just what we've seen already working in the conditions level. Oh, I wish this wasn't so, this was a little bit more ordered, right? But it is gonna work anyway. Maybe we can use color codings so we can better orient ourselves in these levels. So it's less, right? Oh no, this is less than 0. We cannot orient ourselves on this by this. I'm gonna have to build it anew. This is going to be first. No, we're going to start with unsigned less, yes. This is going to be messy and big, at least the way I imagine it. See, what we are going to do is we are we'll search for the first bit that differs. 1, 2, 3, 4, 5, 6. First of all, this is unsigned. And now we're going to build it top down. Let's just move this first. A little bit lower. So if these two differ, right? And this one is true. I'm going to use a different color for this. Let's go with green, since this is going to give us true. If they differ and this one is true, we would know that this one is the bigger one. Is 152 less than, okay. So we would have to take this one, right? So this would show us the case in which this one is greater, which would be equal to this one being lesser. All right. If this is not the case, right? And this one differs. And this one is green. Then we would have green. Also, like if these two differ, right? And this one is green, that doesn't necessarily mean that, because this becomes relevant the moment we add the third bit, that this one is the higher number, because there might be a case where this one is off, this one is on, which would give us a true on this line, but not on this line. So this can only be true if this one is not true. And now we would have to build a chain of gates that look like this. Maybe we should build it from the bottom up. That might actually be easier. Oh wait, we're not going to just delete this. We're going to copy this just in case I made a mistake. And this is actually a good way of doing things. So if you are true, and you two differ, then we are greater. If this is not the case, we're going to check the next lower bit. This is not the case. Then we check if you two differ, and then we check if you are true. That's just the way it's going to look. So if this is not the case, anyway, this is how it's going to look. This one is true. Sorry, it's a little bit messy. I hope you got the concept. Sorry for not getting it right the first time. Right, which one? I guess it is this one. This is a little bit unfortunate. Yeah, this one is going here. So if this is not the case, these two differ. I'm gonna build it like this. And you are true. Yeah, this is the next one. And from here on onwards, we're just chaining up. I guess this won't be it. And we can delete you, since we don't need you anymore. Well, we can take this and not. So now what? First of all, you are going to make this look a little bit cleaner. Since I don't like how messy it was beforehand. Well, this is correct. So the next thing also gave me time to think a little bit, to be honest. So if any of these, oh yes, this one is missing. So if any of these cases, any one of these cases is true, which means we would use an OR. To determine this. We would then output true. I dislike it. Let's do it this way. It's gonna look a little bit cleaner, I hope, at least. Yes, it does. Let's move it a little bit closer together. And this should solve the level. It does not. So where's my mistake? It's 128 less than 127. So these two differ, right? This is not. Or do we need another and actually? Because we need to make sure that there's no difference in these two, because if these two differ, right, this can never be true. Wait a second, let me think. Like these two differ, right? That means that this one is the place where we determine which bit is greater. So only if this is not the case. Let's see if this makes a difference. Only if this is not the case, if these two don't differ, right? Only then. We can we're gonna have to build another AND chain. I have to build another AND chain. I made a mistake, sadly. No, we're not just... In fact, we are going to delete this. But... to delete this part. Put it here. Okay. So the way we do it is... why is there still... this trash bin? Alright. If you don't differ... and these two differ. Can we now chain it up? So if these two don't differ, right? The highest bits don't differ, and these two don't differ, like the highest don't differ, right? And these two don't differ. Only then. If these two don't differ, but these two differ, then we have a case. If they differ, we have a case. If they don't differ, and these two differ, then we have a case. So, what is the next one? If these two don't differ, if these two don't differ, and these two don't differ, so if these two don't differ, and these two don't differ, this makes sense, definitely. This is the chain that we need. So this signal is only ever true when none of the previous cases, when none of the previous bits differ. If these don't differ, this is equality. Let us name this line equality. So this chain determines the first bit from the highest on upwards that differs. So now we will build another AND chain. And this time we actually take 8. If these two differ, and this one is true, there has to be a better way to do this. Anyway. No. You see this, we're going to need in any case. If they differ, and this one is true, then we put out true. If they don't differ, and this one is true, we have to use 3 ways. See, they don't differ. These two differ. One is, and this one is true. Then, and only then, well, let's turn these around. These two differ. This one is true. I dislike how horrible. We're going to connect. We're going to connect the lowest to the first, or the uppermost. So these two don't differ, but these two differ, and this one is true. If none of the previous ones differs, and the difference is in this thing, this is the way it should be built. So this one makes sure that none of the previous ones differ. These lines make sure that there's a difference. And this is the solution. Great. Here we are. Unlocks unsigned less. Interesting. This video came out to be longer than I would have wished. I guess this is not the last level that I might have trouble. And I hope you can, I don't know, forgive me. In the next video we are going to conquer signless. Yes, goodbye. I hope you had fun.